Welcome to today's lesson on the Poisson distribution. And in today's lesson, we are going to look at how we can calculate probabilities by using the Poisson distribution. So first of all, in a bit of background information, the Poisson distribution is a discrete probability distribution and is used to model a number of events occurred randomly within a given interval of space and time. In a particular interval, the probability of an event X occurring X number of times is given by the following formula. And I would make a note of this formula. This formula will allow you to work out the probability of an event occurring once, twice, three times, etc. In this formula, it's e to the power of minus lambda multiplied by lambda to the power of x all over x factorial, where lambda is the mean or the expected number of events occurring for the distribution. When do we use it? Well, we use the Poisson distribution if the events occur randomly, if the events occur singularly, and if there is an average number of occurrences within a fixed interval. So if the probabilities of X are distributed in this way, we write that X follows a Poisson distribution with lambda as the parameter or the mean of the distribution. Okay, what situations could we use the Poisson distribution? Well, any number of situations where a random event occurs. So here are just a few examples. So the first one here, the number of cars passing a road checkpoint in a 5-minute period, given that the average number in a 5-minute period is 4. We would say in this case that X would be Poisson distributed with lambda equal to 4. We have to be careful though when we look at each of these situations and interpret the information that we're given, because on the second example here, it says the number of cars passing a road checkpoint in an hour, given that the average number in a 5-minute period is 4. So we have to assume that over an hour, that given that there are 12 5-minute periods in an hour, that there would be 12 lots of 4 cars passing that point. So the Poisson distribution would need to be amended by multiplying 4 by 12. So in an hour, we would assume that the distribution would have a parameter for lambda equal to 48. You can see that the other situations here on examples 3 and 4, there are many more. Okay, how does that look in practice then? Well, if a random variable x follows a Poisson distribution with lambda equal to 1.4, then we are able to calculate some probabilities from it. So on part A here, how do we calculate the probability that exactly 2 events occurred? Well, in this case, our parameter for lambda is 1.4, and we can use that and substitute in the fact that x is 2. So we would have e to the minus lambda in this case, which is e to the minus 1.4 multiplied by 1.4 to the power of 2 all over 2 factorial. And that's exactly how we would be looking to type that in on our calculators. So if you've got your calculators to hand, this is exactly how I have typed it in. E to the power of minus 1.4 times 1.4 squared over 2 factorial. Now on your calculators, the factorial button is actually just above the x to the power minus 1 button, and you will need to press shift in order to access it. Have a go, type it in. You can see that the answer that I have come up with here on this question for x equals 2 is 0.24166, etc. As with the binomial distribution, we're going to give our answers correct to 4 decimal places, so we're just going to round using the 6. So our final answer for that one would be 0.2417. And we've rounded it to 4 decimal places. Okay, now back to how we interpret some of these questions. So if I wanted to find the probability that X was greater than or equal to 1, then I need to consider what that means. It means 1, 2, 3, 4, etc. So the only number of outcomes we don't consider in this case is the probability that X equals 0. So to find the probability that X is greater than or equal to 1, then we find the probability that X is equal to 0 and take it from 1. In this case, you can either use your formula and your calculator, so it'll be 1 minus e to the power of minus 1.4 times 1.4 to the power of 0 over 0 factorial. If you type it in like that on your calculator and round it to 4 decimal places, you should check that it comes to 0.7534. Should pause the video and make a note of those examples. Okay, now that we've got these calculators, hopefully we have found that by selecting the right function on the calculator, we can actually work these out without actually going into the full formula. So how do we do this? Well, again, starting up, we select from our menu option number 7, and then we would need to arrow down in this case. We do not want the first 4 selections. So arrow down, you'll see 3 options. You need to select option number 2, which says Poisson PD. And then once you've selected that, you need to select number 2, variable. Once you've got that up on your screen, you will see that there's 2 things that you need to input. You need to put in X, which is the number of times the event occurs for the probability, and lambda, which is your parameter for the Poisson distribution. Once you have input that data onto your calculator, you will see that it will work it out for you. So if I go back to example number 1, part A, the probability that X is equal to 2, you need to type in there that X is equal to 2. You type in your lambda value 1.4. Once you've put all that information into your calculator, you could see that exactly the same result came out as using the formula. So again, we can see how useful our calculators can be to help us out. Okay, so another look at another question then, for example 1. So what's the probability that X is greater than 2 and less than or equal to 4? Well, in this case, this implies that X can either be equal to 3 or X could be equal to 4. So by adding those 2 probabilities together, we can come up with our solution. So at this point now, you can either use the formula that I've shown you for examples A and B, or you can use your calculator to work out the individual probabilities. So this is a check for you. Pause this now and type the information in on your calculators and then check your information. So for the probability that X is equal to 3, correct the 4 decimal places would be 0.1128. And for the probability that X is equal to 4, it would be 0.0395. And that again is correct to 4 decimal places. And then your final solution, when we put those together, will be 0.1523. And that is your final solution, correct to 4 decimal places. Right, let's have a look at it then in a context. So a life insurance salesman sells on average 3 policies per week. Calculate the probability that over a fortnightly period, this salesman will sell 4 policies. Well, first of all, we need to note that in this question, he sells on average 3 per week. Well, we are being asked to calculate the probability over a fortnightly period. So over a fortnightly period of 2 weeks, then we would expect him on average to sell 3 policies for each of the 2 weeks. So in this case, the distribution would follow a Poisson distribution where the parameter for lambda is equal to 6. So if I want to work out now the probability that he sells 4 policies, then I would need to work out the probability that x is equal to 4. So again, I can either use the probability formula, so e to the power of minus lambda, e to the power of minus 6, lambda to the power of x, in this case that's 6 to the power of 4, all over 4 factorial, or going back to your calculator and adjusting the parameters in there. Here's a check for you, 0.1339, and again, all answers are given correct to 4 decimal places. What's the probability that over this fortnightly period, this salesman sells some policies? Well, just interpreting that he sells some means that he sells one or more. So that's asking us to calculate the probability that x is greater than or equal to 1. Well, that's 1 and above. So to work that out, the quickest way would be to work out 1 minus the probability that x is equal to 0. And again, you can use the formula or your tables to support you with this, or the calculator to support you with this. So 1 minus the probability that x is equal to 0, which calculates to 0.0025, and then working out the solution from there to 4 decimal places, 0.9975. Okay, I hope that's helped you understand a little bit about how you can calculate a probability using the Poisson distribution. What I would like you to do now is open up the main task that I've attached to the assignment and have a go at those questions. When you're done, please have a look at the check-in question on the next slide and have a go at that too. If you need anything at all, please just message me with the information. Good luck.